Now, if you've got a taste for nice bike accessories, then you've probably heard of a brand called Silca. Dave sat down with CEO Josh Poertner to talk about 3D printing, thermoplastics, and what's coming next for Silca. It got proper nerdy, so grab a coffee and enjoy.
Josh, thanks ever so much for joining us. It must be almost 10 years now since you took over at the helm of Silca. Is that about right?
Ooh, yeah, it'll be December. I think our official date was December 10th of 2013. So
So you've got another year to go.
Another year for 10,
Yeah.
but yeah, it's coming up. It's been crazy fast.
Yeah,
Really.
Absolutely. And at that point where you took the company over, it already had like a 90-something year history.
It did. It was 2017 was the 100th year anniversary. So yeah, we had 4 years to prepare for the 100th. or 3 years to prepare for the 100th, I guess. Once we took it.
And how did it feel taking over a company with that much kind of background, that kind of huge history? Was it a frightening thing to take it, move it somewhere different, and kind of not start again exactly, but just start with a new kind of leaf?
Yeah, well, and honestly, I think what made it very freeing was that the company had fallen into like a receivership, like a sort of a bankruptcy in Italy, and the only thing we could get from that was the trademark. And so we had the history and the brand recognition, but at the same time it was kind of liberating that we didn't there was nothing else there to even buy. I mean, we wanted to take. He had this great old lathe and some of the historical documents and posters, and those things weren't even an option for us. It was you can't even have the posters off the wall, like the government owns those. And so in a way, I think that first day I remember sitting down in my living room at this table, and I had this laptop that I bought and this piece of paper with the trademark on it, and was like, oh, okay, we are starting from nothing other than the vision that we want to do right by this amazing old brand.
And obviously you'd come from a position where you were a user of Silca products as well for a long time. So was there certain things that you saw in the brand that had really kind of resonated with you as a cyclist and as a kind of mechanic and technician?
Yeah, I think when I first heard from Claudio, who was the owner at the time, he had pancreatic cancer. He was dying. He'd just been given a few months to live. The company was in trouble, and he had actively been trying to sell it for about a year, and nobody wanted it. And I remember hearing his story and, kind of thinking at the time, oh man, who wants to buy a bankrupt pump company in Italy of all places? You'd have to be nuts. And then the more I thought about it, really was my own experience of, I got my Silca pump when I was, 15, working in a bike shop, and I tell the story all the time. I love it. But Dan K-Spear, a great, former pro cyclist here in the U.S. and just a lovely guy, owned the shop. And I remember him telling 15-year-old me, the Silca pump was like $80 at the time, which, 1992, and he'd be like, "Oh man, it's so expensive for a pump," And he said, "Look, kid, there's two kinds of pumps. There's crap and there's Silca." He's like, "Just buy it. You won't regret it." And you think back and think, my God, my tenure at Zip, the pumps in the employee bike room. I mean, my God, we replaced them every 3 months. I had just earlier that year lost something like 6 hours of wind tunnel time because we had two pumps with us that we traveled with, and they both broke in the same test. And, they were like the nice, shiny, silver, new fancy pants pumps, that were really popular at the time. And you go to a bike shop and you're like, oh man, okay, I can get a Silca old school brass Presta chuck and a hose clamp, and we can rig this thing to work again. Yeah, and then it just started from there. I thought, really had this moment of I'd spent 15 years of my career doing super high tech race stuff, and we were obsoleting our own technology every year, and it was really a fun ride. And then I look at my own bike room, and it's like, okay, well, everything I've ever lusted for in this sport is in a landfill somewhere, except for that campy T-wrench and that Silca pump. and my vintage, Eddie Merckx steel frame. The rest of it had just become disposable, and so it just felt like something cool. Like let's go make a modern take on not disposable stuff, and that really helped me. I don't know, pull the trigger on buying the brand, and then too, you lay in bed at night and think of things like, like, gosh, why hasn't anybody just made a valve extender that like works? And the bar here is low. I mean, I remember the first year of the company, we would get these great emails from people like, "Oh, I bought your valve extenders. They're amazing. They work." You're like, wow, that is a low bar. When like something actually doing what it's supposed to do warrants a happy email from a customer, it sort of tells you the state of things. And so I think as we've grown into all these other categories, it's my vision has always been, can we bring new technology to either make it work better, or in some cases, sadly, I think we're just making it work in the first place for people.
And of the things that you brought to market, of the different products and the different areas you're in, what are the products that you're most proud of at Silca?
I guess in some ways, all of them. I think if I have a specialty, as an engineer, as a company owner, I think it's kind of being able to look at the world, assuming that most of these problems, if you break them down to kind of first principles, somebody somewhere has solved all this stuff before in some other industry or for some other purpose. And if we can just be really open-minded and a little bit clever and willing to talk to folks, I think we can do some amazing things. And so I think of it. It's not my favorite product, but like our take on bar tape, right? We've done all this work on vibration. Like, oh, okay, you don't want damping in your bar tape. You want undamped suspension in bar tape. Well, man, Nike just launched that 2-hour marathon shoe with that super special foam from Arkema Chemical. That's like the best rebounding foam ever created, and it's really light. Oh, that'd make a great bar tape. And then we look at it and go, oh gosh, but it's not durable. Oh, well, the Oakley's unobtainium nose piece material, that's like hydrophobic and it's got this great feel. And I wonder if we could laminate those two together. And pretty quickly, it's like you make a couple of phone calls, you talk to some people, you make some terrible prototypes, right, on a table that people look at of like, that's not bar tape, that's awful, and like, no, see the vision here, like, we can make this good. And a year later, you launch a product, and that one for us, like, Tour Magazine in Germany did a laboratory test, and 22 brands of bar tape. We're the new guy on the market, and we win the overall, and we win, I think there were 5 categories, and we were first place in like 3 of those categories. And, for me, that's just super fulfilling, because it's like, wow, we just by stepping outside of ourselves and talking to people who were smarter than us in areas that weren't bikes, we did something really cool. And I think we made a whole product category a better place. I mean, look at, I think the stuff we did with lubricants, in a way, I think we showed up in lubricants and kind of, kicked the industry in the nuts a little bit, by doing something just totally different. But we didn't invent that. I mean, I knew somebody who was in F1, and we're talking to him about what they were doing, and he's, oh, you should read these research papers, and we did a lot of stuff based on this, and and then it's just putting in the hard work to try to figure out how to make the best decisions along the way. But I didn't go get a PhD in chemistry and like invent a new chemical compound or something. I just was open-minded enough to go find people much smarter than myself, and ask them what they would do.
And the Synergetic is a great lube. I've used it for the last 9 months in UK conditions, which can be challenging, although at the moment they're not. And it's been great. So what specifically did you come looking for a lube, or is it just that you got chatting to somebody and that was the direction that went in?
So lube for us was interesting. I had been waxing chains for 20 years, and when Jason Smith had Friction Facts, and he was testing and make kind of coming up with like, oh, what's the fastest hot melt we can make, and the data, probably late 2000s was clear, like this hot melt really was the future. So I was hot melt waxing chains for Cancellara and '08 and stuff like that. We'd go to the Olympics and play around with recipes we found on the internet, and so I'd kind of been, I guess, preaching that gospel for years, and really had this vision of like, oh, if we could put this into a drip form for normal people, this would be a killer product. And I think the irony of that is, I spent so many years trying to figure out how to make a good wax emulsion that would penetrate, that the technology changed. And we learned about this tungsten disulfide kind of synergistic reaction with this other material, that, it's kind of like a 1 + 1 = 10 sort of effect, right? It's like each of these things on their own are 10% better, and you put them together and it's like 90% better. I mean, like literally that's how the math works on this one. And it's totally unexpected. And, it's kind of like magic, right? Right? Like it doesn't make sense, but let's leverage this. And so the technology changed and we started using that in the hot melt. And I still thought nobody's going to buy hot melt. And then COVID hit, and we sent our employees home. And I remember thinking like, okay, I literally sent them home and said, I think we probably have about 10 weeks of cash to pay everybody. And I hope I see you guys again, right? I mean, if it seems a little crazy now, but if you think back to the beginning of this, I mean, those were some scary times. And,
there were. Nobody knew where it was going to go.
Yeah, it was. And so, I have a little lab at my house, and I'd been doing all this work at home. And I think it was a day in, I remember, just being like, screw it. I'm going to like buy some bottles and bottle this stuff and like, let's sell it. What do we have to lose? And so we started selling the drip wax literally from my house. And there was this crazy interest, but I think, even more surprising, right on top of that initial interest, people kind of went, oh, well, yeah, but in your story, you talked about the original hot melt stuff. We actually want to buy that. And I'm like, oh crap, I never thought anybody would want to buy that, And so then that became and of course, here we are a couple of years later. I was just at the Leadville 100, and it's funny in the world of mountain bikes, and people are coming up with like, oh, no way, you guys make pumps? That's so cool. We thought you just made lube. And it's like, oh, we've discovered this whole new audience that they now know us as like the lubricant people, and like, oh wow, when did you guys start making pumps? Oh, about 105 years ago. So I would say if a lot of the technology areas we get into can seem crazy, but they're typically all coming out of some, the core of our company is a company called Aeromind that still does a lot of consulting to world tour teams and triathletes and bike brands and component brands. And so my background being kind of high technology, aerodynamics, composites, things like that. We do a lot of consulting in these spaces, and what that really opens up for us is, and it's actually in our agreement that we have with the teams or the companies that hey, after a 3-year like a sunsetting period, we can turn ideas that we've come up with here into products, right? And so some of the things that we're into now, I think a lot of our like the 3D printing and stuff like that. I mean, a lot of that is we're you see these guys riding these crazy handlebars or crazy custom components for time trial or whatever. A lot of that is stuff that we're we got into 3D printing to be able to solve problems for those teams or those athletes, and in time that's stuff that'll eventually become available to the public. So I think for me it's kind of a cool way of trickle down. Like you can really see those trickle down effects of the technology from people, and it's expensive at first and it gets cheaper in time, but hey, you have access to it. That's important.
I mean, let's talk a little bit more about 3D printing. So I was going back through the road.cc archives to see how long ago we first mentioned 3D printed components. And it was actually about the same time that you were taking over at Silca, as just sort of end of 2012. Charge was starting to make 3D printed titanium dropouts to put in a cyclocross frame. I think they only made 50. But we haven't really seen that technology hit the mainstream yet. I mean, in a big way. Do you think that's something that's coming?
Oh yeah, I've bet my company on it. and yeah, the thing I see in 3D printing is that it, in some form or another, is 100% without a doubt the future of how everything will be made. Now, that's not 5 years from now, it's not 10 years from now, but if you give it time, that's how everything is going to be made. And I think it really will check all the boxes, right? It's quite environmentally friendly. Compared to what you'd think of as like subtractive manufacturing. If I buy a kilogram of titanium powder, I can make about 960 to 980 grams of parts with that powder. If I buy a kilogram of titanium bar stock, I'm probably going to machine it into something that weighs 100 grams and end up with 900 grams of chips that will have to be washed and rinsed and transported and melted, right? And all of this complicated stuff in order for that to be recycled to hopefully come back, as another piece of titanium that I'm going to use 10% of. And so, that's 3D printing in the industry. People say additive manufacturing versus subtractive manufacturing. We're adding the thing together instead of taking it apart. So that aspect of it, I think, is really fascinating and has some interesting environmental aspects. But you think of if we build a colony on the moon or on Mars, you're not going to send lathes and mills and multi-turn axis turning machines and then send bar stock and plate stock and square stock and hex stock. No, you're going to send a handful of 3D printers and a bunch of powder, and those things from that powder can make everything else. It in time will be, and then I guess on top of that, they can make one of something. They can, you look at some of the projects, the Dowsett hour record, project we did. I mean, from the first phone call that said, hey, we need to cut the rear end off of a TT bike and bond in a 3D printed rear end, and we need it in 3 weeks. From that first phone call to the first prototype was 2 days. Then we lightweighted that prototype, ran some analysis on it, did some actual physical testing on it, changed the design, started to print the next morning, printed it for 14 hours, pulled it out, drove it to Rolls-Royce to heat treat it, did a little bit of finish sanding on it here and there to clean it up, and had it shipped on the Friday. That's not even, you can't even begin to think about that with other technology. But then on top of that is, once that model's in there, I need one of those that's 10 millimeters longer. Okay. I mean, I can have that printed for you by tomorrow. I think the future, I mean, particularly in this sport, 3D printed frames are a long way away. But eventually you'll get measured and we'll just print you the bike to match, or we'll print your handlebar to match, or, we're already getting to, 3D printed saddles using this Carbon. Carbon's the company that makes the machines. Technology, what you see from Physique and Specialized and those guys, that's all the same technology from the same essential machine. But that's a couple of keystrokes and some software training away from like, hey, sit on this thing and we're going to map your pressure points, and then we're going to have an AI design the saddle with foam or the printed density to match those pressure points, and you'll have it tomorrow, right? That's not far away. I mean, that's probably next year. That technology is pretty robust. And so I think, if you just think of it directionally, this is the future. And that's where, as I looked at it, it was like, okay, well, the machines are really big and expensive and all these other things, but 10 years from now, everybody's going to be doing this, and the world will be divided into the people who built that world and the people who are coming to the party to go, oh, what's up, guys? Let me learn this. And I would way rather be in the driver's seat driving into that technology from this end going, hey, it's not perfect and it's not great for production, and it's not, fully robust yet, but let's be part of that future. And I think as a result of that, we don't just use Renishaw machines. We're actually a technological partner of theirs. We get access to new powders that are coming out, new updates, new features, because we're doing a ton of printing of a ton of different types of parts for a bunch of customers. And so we're able to give them, really quick feedback to tighten that loop. So, even if we couldn't find a way to be profitable printing in 3D, I would still be doing it because I think we're directly shaping the future that's ahead of us.
That's great. How long do you think it's going to be before I can get my custom 3D printed frame? We've been talking about it for a long time.
Yeah. The challenge now is really size of the printable area. And the thing that makes the printable area a challenge is you think you've got this sort of like bed of powder and you're using a laser to weld a layer of powder to the layer below it. And one of the fundamental problems you have with these things is the focal length of the laser changes as it moves around that bed. And so like right now, your printable area in most machines is something like 12 by 12 inches. And you can go probably 14, 15 inches high. And that's about the limit of the focal length of a single laser. Now, all of our machines are 4 laser machines, which at the moment, that technology is really just so you can make more, I can be lasering 4 parts at a time instead of 1. So it has 4 times the throughput of a single laser machine. But the future is really going to be kind of gangs of lasers. You're going to have 8, 12, 16 lasers, and they're going to be spread out through the machine so that the parts can physically get bigger. So you can have multiple lasers lasering, a single part all at the same time. And that's really just that the technology is being worked on. We've actually seen prototypes, and then you just have to get into things like, well, what sort of structural things are happening at like laser to laser boundaries. If the 2 lasers are working on the same part, that they have to intersect at some point. What's the software have to do, or the strategy have to be to make sure that laser overlap zone is as strong as the rest of the part. And, they're really super geeky, technical, hard, challenging things to solve at this point in time. But the reality of those is, we are going to solve it, and somebody's going to get their, a PhD out of it. And a month later, the whole world is going to know, oh, well, yeah, clearly you solve that by doing this. Duh, and we'll move on. I mean, that's how the technology marches forward. And, so it when these things get solved and how quickly they can come to market, I have no idea, but it's the progress that's happening all around us. I mean, every time I go into Renishaw, talk with them, work with them, see what they've got, it's like, holy crap, this, I joke that the technology moves forward a year about every 2 months.
Right.
Because they're just doing so much in so many places at the same time that, there's this scale of progress that's super exciting. So, it's not next year that you get your 3D printed bike, but I would say it's not 10 years from now. Okay. It's probably sooner than that.
3D printing, obviously a very big trend. What other trends are you following closely at the moment in the cycling market?
I always try to have my ear to the ground on materials in all aspects, because I think the future of everything is really going to be driven by new materials. I think the most exciting thing currently happening is thermoplastic resins for carbon fiber. That I've been in the composites world for 25 years, and we've been talking about thermoplastic materials the entire time, and yet it just keeps not happening. But it sort of feels like we're almost getting there. I mean, there's a company now here in the States using thermoplastics to make some rims. I think, we're going to start to hopefully here soon see some at least small scale bike production using thermoplastics start. We're actually part of a technology in manufacturing working group at Purdue University here in Indiana, which is a top technical university, and we're actually working with them on doing some pretty amazing like automotive parts using thermoplastics. And that's exciting. The thermoset resin that's been used in carbon all the way up until now really completely prohibits that material from being recycled in any meaningful way. I mean, you think of like our tire sealant has recycled carbon in it, and we make that by literally grinding up old bicycle frames and wheels and the occasional race car part, and superheating it in a vacuum called pyrolyzation, and burning the thermoset resin off, which actually turns into a liquid that can be turned into jet fuel. But that's the only way to get back to the raw fibers. And of course, the raw fibers are now all short and chopped up because you had to do that in order to burn the resin out of them and free them. And so, it's really, in a sense, it's more downcycling than recycling. You're taking this very exotic, expensive thing and turning it into kind of a cheap, much less useful thing. And then, we can give it life in a sealant or as a reinforcement in another type of, glue or whatever. But you could not turn that into another bicycle. And, the future with this thermoplastic resin system is you can basically melt it, keep the fiber length long, and potentially someday the technology will exist that, the hood of a car can be, softened and remolded into the hood of another car, at some point in the future, or something along those lines. So, that's 25 years I've been watching that, be talked about and shown off, and just now we're starting to see it happen, but it's still in its infancy. So, but yeah, I mean, that's like tip of the iceberg, right? The, materials and, lubricants and sealants and waxes and coatings. And, we're working a project right now with the lab at the University of Manchester and Cambridge, who discovered graphene. And, that stuff is fascinating. And we actually have a couple products that hopefully we'll be able to get to market here soon.
Oh, cool.
Using graphene, which is super exciting. And here, I'll actually show you I know this is a podcast, but this is a little thing. This is 25 grams of pure graphene made in the lab that discovered graphene. And this little jar here, it's maybe 2 golf balls in size. That's around $700 of graphene in that little jar. But it is like magic, and some of the stuff that it can do. And, I look at that and go, okay, well, it's crazy expensive now, but it won't always be. And so what can we do with it? And it's one of those cool materials that pretty much about everything we've dreamt up to try with it, it's been exceptional.
It seems to just be good at everything. It seems that you can add it to pretty much any product.
Yeah, we joke with the lab. I mean, the hardest thing about, or really the only bad thing about graphene, is that almost all of it in existence is not real. and it's funny. I mean, we played with graphene for years, and I could never make it do anything. And when I finally, I guess it's a good story. When I lecture engineering students, I always tell them, like, take a stab. Call somebody, email them. Like, if you read a research paper, like, send that person an email. They would love to talk to you. And I'm having terrible experience with graphene, and I'm like, screw it. I'm going to contact the lab that invented this stuff and see, like, what the hell am I missing? And the beauty of people being people, especially like really geeky people being really geeky, is like, they love to geek out on this stuff, right? And so you call them and they're like, oh my God, like, yeah, we're dying to talk to people about what we do, this is awesome. And so, you have like a 1 hour Zoom call, and I send them a bunch of the graphene and the products that we've tried to test with graphene in it. And, they pretty quickly, they're like, oh yeah, that's not, you've been had, that's not graphene. They're like, well, shit. Okay. I want what you've got, but I do love that about what I do. I get to talk to the guys that discovered / invented graphene one day, and I'm down at Rolls-Royce jet engine here in town, dropping off parts for heat treat, and those guys are going, "Oh man, you should come look at this fan blade," and then of course, that kicks off a million ideas, and I mean, that's actually an example that one of our contacts at Rolls-Royce, they laser welding is the only type of welding you can use on some of these titanium jet engine parts, and that's totally what threw us in that direction to start making the titanium bottle cages that are all laser welded. It's like, oh wow, you can weld disparate wall thicknesses, and you can weld way smaller than a human hand, and what could we do with that? Oh man, you could make a killer bottle cage with that. And I don't know, there's just something to me that's so cool about people's willingness to be awesome with stuff like this. Even within the industry, it's pretty rare that you ask a good question of somebody who's doing something cool and they blow you off or tell you like, "Oh, it's trade secret, piss off," or whatever. People love, they just love to geek out on this stuff, and they love to share that. And that's amazingly true if you're, an aircraft designer or a race car designer, or, PhD in a lab that won a Nobel Prize. People really can be awesome, and I find that super inspiring.
You've got a bunch of products out there already. You've got skin in the game in a couple of different ways. So you're tubeless and your latex tubes. So which camp are you? Are you a tubeless guy or are you a latex tubes guy, or does it depend?
Oh, it depends. So like the Dan Bigham hour record was just set was latex tubes, Silca latex tubes. They are still the fastest thing going with the right tires. In my personal life, I'm pretty much all in on tubeless because most of my riding is commuting, and I have a very crazy, hectic schedule, and I maybe get out for an hour a week, every other week or something. And I tubeless is great for that. I mean, I think, in the course of commuting to and from work, I know when we were developing our sealant, I think I had like 5 or 6 punctures that I didn't even know I had, right, until I got to work. And you spin the wheel, or you're walking the bike and leaving little sealant spots on the floor. Like, oh crap, I got a flat on the way in and I didn't even know. I mean, how cool is that? And I think that the enabler there, really has been the tire technology and the tires getting wider so that the pressures could come down so that the sealant can work. So I would say if you're doing something where you're over, 80, 90 PSI, latex tubes all day. And if you're doing something where you're under that pressure, and you're not, racing for a paycheck, then I'm all in on tubeless, but it's still, tubeless for me is like where it feels like it should be 100% buttoned up and solved by now, and it clearly isn't. But I think some of the new ISO rules in place on some of the sizing and fitments and some of the technologies we see from the tire companies and the wheel companies, I think it'll be truly, truly robust in 3 to 5 years at a level that, it'll just seem like the obvious solution for everybody doing everything. Except for maybe our record attempts, but you never know. We a little bit of tire technology improvement. It's not far. The best tubeless tires aren't far from the best clincher tires with latex. So maybe we're just a couple small advancements away from those two matching each other or going in favor of the tubeless tire.
And after doing all that work on your drip lube with the wax technology, do you still hot melt, or are you a convert?
Oh, I totally hot melt. Yeah. The difference, the difference though. So it's I think we're the only company where the two products are identical, except that the drip lube has to be emulsified into something, and for us that's about 20-ish% water with a little bit of alcohol in it to help it evaporate. And so if you think of it just purely from a like filling up the voids in the chain perspective, when you hot melt, the chain is 100% full of wax when it's in the wax, and you pull it out, and as it hardens, it's 100% full of wax. If you drip the wax on, you have to wait, 12 hours or so for the water to flash off, and now the chain is 80% full of wax. Now, you do the math, you do a second application, and you can take that to like 96% full of wax. But you have to wait 12 more hours for it. And so the way I do it is I hot melt. Actually, our little studio here at Silca has our hot melt set up in here. All of us pretty much commute in and throw our chains in there, every once in a while. I hot melt, and then after about every third ride, I wipe it down with a microfiber cloth, and I put the drip wax on as like a top off, and that'll stretch out the duration between hot melt considerably. But it's also, we have the unfair advantage that we've got a massive ultrasonic hot melt bath in the factory. We've got multiple like crock pot and instant pot setups here in our studio that we use in video. Like the reality for me is, hot melt waxing a chain is like a 2-minute procedure with a bunch of really cool equipment that I already own. So I think for, the average person, who's interested in experimenting here, like just start with the drip wax, and if unless you're really into like the technology, like some of us are, the difference is so minor. It's so minor.
So you talked about tubeless, and obviously there is still an issue at the top end of pressure with sealants working. I mean, we've seen that. I've seen that. Some of my shorts can testify to that. But tire pressure is always a big thing. And you were saying to me earlier, it's like still like a massive part of your inbox is people asking you the question.
Yeah.
I mean, how has it changed in the 10 years that you've been, or the 9 years that you've been running Silca? It's quite a different environment now.
Yeah, that's a great question. It's funny. I have often said it feels a little bit like the sort of adoption of carbon wheels. In like the early days of Zip, we were just trying to sell. We weren't even trying to sell Zip wheels to people. We were trying to convince people that carbon wheels were a legitimate thing that they might want to look at. And then, kind of like a light switch, we always joke, 10 years later, you're an overnight success. It's like the light switch flips and the conversation is like, well, duh, of course I need carbon wheels, but which ones? And I think people certainly, like in that company, people who came later were, they never had that experience. It's like, oh no, I've stood in front of a bike shop owner for, an hour just trying to explain like that aerodynamics were real, and I would say the tire pressure thing has been a lot like that. In the beginning, people just thought we were nuts. And some of that, honestly, the big discoveries we made at Zip surrounding the Paris-Roubaix pressures and the pressures for cobblestone, this whole idea of like lower was much faster. I mean, it wasn't a little bit faster, it was a lot faster. And that became a really like strategically important piece of knowledge that we kept very secret because we didn't want athletes that weren't our athletes to know it. And so I think, from there, we at least had a little bit of history when we did kind of come out publicly and say, oh no, this is how this works. This is a big deal. Your pressures are probably too high. We at least had that sort of use case proof, so to speak, that, we're not crazy, right? I'm not like some random guy on the internet, with some theory, and so that helped. But yeah, it's still, for years, you would go to events and, we joke, we've got this thing, we call the inflation station, we take to rides and races and we probably spend 90% of our time letting air out of tires rather than putting it in. And then all of a sudden in the last couple of years, and I think, other companies got on board, people started kind of also putting out, tire pressure calculators, because ours has been, I think, really popular and successful. And so there's now probably half a dozen of them out there. But the pendulum now feels like it's kind of swung a little bit the other way that, you kind of get to people coming in with like, oh, well, your calculator said 57, but, I know that, 45 feels much better. Like, well, I'm not going to lie to you. I'm sure it's more comfortable, but, be careful of those pinch flats. And so it's funny that people will argue with me or write into the inbox to tell me that, our calculator is telling them to put more pressure in than they want to. And so I think, I talk a lot in the marginal gains work that we do. Humans are wired for maximize, minimize type problems, right? Some is good, more is better. Less is good, none is better. We are not wired to handle these optimized type of problems well, and so, it does become kind of the swinging pendulum. We've definitely, it feels like for a lot of people, moved into this less is better phase. Where really the right answer is that the optimal pressure is the right pressure, and we're definitely now finding that for some people it's a lot less than they've been using, but for other people it's probably a little bit more than they've started using. And I'm excited there. I think there's a lot of tools. People send me. We use a lot of our own kind of homebrewed tools, but people send me all the time. The error sensors and power related tools and ways of measuring. Hopefully CRR with a phone app, and we play around with a ton of that stuff, and quite honestly, none of it right now is very good. But it's coming. It's way better than it was a couple years ago. So yeah, I don't know. Is that 3 years? Is that 5 years? I'm not sure when that is, but there will be a time where you will have some sort of tool and you can go ride and test and go, oh yeah, for this road, this is too much pressure based on this data. And at that point, no one will have to listen to me go on about it anymore. But I do love that the inbox you mentioned, is so funny that people will come and like use our calculator and then come to the inbox and like argue with you about it. It's like here's how the calculator works, and we're trying to be as transparent as possible, and if you want to do something different, I'm totally fine with that. But it is based on like thousands of like real data points taken in the field with real people, and then trying to extrapolate the missing sections. I'm not claiming to know 1,000% of your exact situation, but we're just giving you a best guess tool, and it's free. So
Great. Well, Josh, thanks ever so much for your time. It's really nice to speak to you, and we'll hook up again soon in the future.
Hey, thanks so much for having me. It's been a pleasure.
I don't know about you, but I'm now really tempted to knock a bit of pressure out of my tyres. Anyway, I hope you enjoyed that in-depth discussion. If you have any questions for Josh, then pop them down in the comments below and we'll do our best to get them answered. Remember to like, subscribe, and we will see you in the next one.